Hey everyone, so in this lesson I'm going to go over lesson 6, factoring trinomials. So it says to factor trinomials where the a value is equal to 1 using the AM method. The AM method is the method you should be familiar with from Algebra 1. AM stands for add, multiply. Okay, and the reason why we have it in this order is because of something I will show you in this lesson, because this is more of like a refresher lesson, because you should be able to do most of it. Alright, write a trinomial whose a value is 1. When they say an a value is 1, this is why. The basic form of a trinomial is this. Ax squared, hold on, let me write that a little bit better. My x is a little weird. Ax squared plus bx plus c. Where a, b, and c are constants, coefficients. This one would be a constant though because there's no letter next to it. These guys are coefficients because they're numbers in front of letters, and then x squared and x are variables. So when they want the a value to equal 1, we want a equals to 1, so any trinomial that basically has nothing in front of the x squared, which really is 1. So if I wanted to write an example of a trinomial whose a value was 1, I would just do x squared plus, I don't know, maybe 6x plus 9. Okay. A trinomial is a polynomial with 3 terms, keyword, and that is tri, like tricycle has 3 wheels. The degree of the quadratic must be 2. Quadratic means highest power is x squared. In other words, there must be an exponent of 2. That exponent must be the greatest exponent. Okay. The steps to factoring a trinomial in this form using AM would be to write all the factors down of C. So C, you would try to find the factors of it. Identify what of the factors add up to the middle number, which is the B value, and then substitute the factors into the 2 binomials that you create. So that's where the AM method comes from, because you need to add to B but multiply to C with your numbers. So it says that the trinomial in your do now factorable. Well, let's take a look at this thing. So the trinomial that I made would be x squared. It's x squared plus 6x plus 9. That was my example. So I got to figure out my factors of 9. Well, there's 9 and 1 and 3 and 3. I have to ask myself, well, does 3 and 3 add to 6? Or does 9 and 1 add to 6? And I would choose 3 and 3. Now, side note, you could also do -9 and -1 and -3 and -3, because when you multiply 2 negatives, it does still become that positive 9. But I really don't need to worry about that because 6 is a positive number. So is it factorable? The answer would be yes, because when you make it into 2 parentheses, when you factor this using AM, you're going to split the x squared up into 2 of these. And then the 3's are going to go here, because what you're doing is you're breaking up the 9. This is being split, okay? And then I want to add to a positive 6, so it'll be plus and plus. Alright? And if you don't believe yourself that you wrote it right, you could always go backwards, because remember, like I talked about in the last lesson, factoring is division, really, of a polynomial. You're dividing it up. And to get back to where you started, just do the operation of multiplication that's in between. So like x squared, 3x, 3x, and 9, using the box method. You could also check with FOIL if you'd like that. You get x squared plus 6x plus 9, and you know you did it right. So that's the factoring of that example that I created. Okay, so we're going to factor the trinomials here. We're going to use the same process I just did, and hopefully you guys will get it from here. So this is all review, like I said, and the last lesson we talked about dots and GCF, and dots, the thing about dots is you only need 2 terms, so it's a binomial. This is the way that you would factor a trinomial. Okay, so you need to remember that with a trinomial you want to try to do AM. Of course you want to check for a GCF first, but that's factoring completely, and that's another lesson. So using AM, I'm going to break this up into 2 pieces, x and x, and I'm going to ask myself, what are my factors of 4? Well, it's 4 and 1 and 2 and 2. And which ones add to 5? And that would be the 4 and the 1. So 1 times 4 is 4, and 1 plus 4 is 5. And what kind of 5 do I want? I want a positive 5. So I'm going to add plus plus. Okay? Next one. I see a trinomial. I see that the highest power is x squared. So that means I'm going to try to do AM to factor this guy. And again, what we're basically doing is just breaking up the polynomial, just dividing it into two pieces. And I'm going to have x and x because I'm breaking up the x squared first. And then I'm going to try to figure out what the heck 32 factors into to get me 12. Now, if you're not sure of your factors of 32, what you could do is go to y equals and do 32 divided by x. And then look at the table. And when you look at the table, you can see the factors in the xy. So like one of the factors I would see, and the one that works for this, is the factors of 32 that add to 12 are 4 and 8. So I would see 4 and 8. And those are the ones I'm going to use. And I want a positive 12, so I'm going to do plus and plus. Okay. I'll do a little calculator video attached to this lesson to show you that trick. I just don't have a calculator on this particular platform that I'm using, but I will show you the how to find your factors trick in that video. Okay. All right. So again, we're going to break this up. Okay, two sets of parentheses, x and x. What are my factors of 50 that add to 15? Well, I got 2 and 25. I got 1 and 50, obviously. I got 5 and 10. Boom, that adds to 15. Because remember, add, multiply, AM method. So 5 and 10. And then I want a positive 15, so plus and plus. Next guy. Okay, I'm going to break it up. Now if you notice, it's the first one that we've had with different signs, like negatives. So here's the deal. This is going to be different. Whenever the last sign is negative, the signs have to be different when the last signs are negative. So that means that this needs to be a positive and a negative. Because this is AM method, your goal would be to multiply to a negative. And the only way to multiply to a negative is by multiplying a negative and a positive. Okay? So let's make our factors of 24. We got 1 and 24, we got 2 and 12, we got 8 and 3, and 6 and 4. I'm sure there's others. No, I think that's it. So I want to find the one that somehow adds to 5. Now, I know that none of these values add to 5. Like 1 plus 24, that's 25. This is 14. This is 11. This is 10. So nothing's adding to that. But remember, our signs in here have to be different because technically this is a negative 24. So one of these guys, like either the negative one has to be negative, or you can make the 24 negative. You can make the negative 2, or you can choose to make the 12 negative. You can make the 8 negative and make the 3 positive, or make the 8 positive and make 3 negative. There's all these different combinations that you can do, but you have to find the one that works. So then I start to think, well, if my signs need to be different, that really isn't adding. It's more of subtracting in a way. So if I subtracted these numbers, which one would really get me to 5? And that's the 8-3 combo. Because if I do 8 minus 3, I get 5. But here's the hunch. There's a negative in front of here, so just be careful who you make negative. So in order to get a negative 5 with 8 and 3, you need the 8 to be bigger, and then the 3 to be, you would need the 8 to be negative to get you to that negative 5. Now there are ways to check this if you're not sure that you factored it correctly. And that would be using your calculator, number one, or you can substitute a number in for A and see if it gets equal. Because ultimately, this is equivalent to this. What we're really doing is just breaking this up into two pieces and factoring it into a product that would, if you wanted to, multiply it back to this. Now, of course, you can check with box method. That's the one way I showed you. But the other way is to use your calculator. There's a few ways of doing that. You can put this into y1 and this into y2 and press graph, or look at the table and see if the points are the same. If that's true, that means that they are the same function. Or you can substitute. If you put, like, say 1 in for A here, and you put 1 in for A here, and you plug this into your calculator with the 1 substituted, and you plug this into the calculator with the 1 substituted, they should be equal. And if they're equal, then you did it correctly. But I'm going to in my calculator video, I'll show you the trick to checking. Okay? Alrighty, so again, trinomial with the highest power is 2, so I'm going to try to do my AM method. Now I'm going to keep close attention to the last sign. You're going to start to realize that the last sign really, he rules. He tells you what's going to happen with these parentheses. That last sign really sets the tone in the way that when you multiply, if you're multiplying to a negative, we definitely need opposite signs, okay? And then you can go ahead and do that whole breaking it up. And if you notice, this one here, 5, is the same question as 4, except, let me make this a little bigger so you guys can see it. I changed the 5 to be positive, where the 5 was negative in this one. So it's the same factors, but who's going to be positive this time? 8 and 3 are the ones we're going to choose, but I want to make the 5 positive, so this would be the reason why you would make it 8x plus 3 instead of x, minus 8 in the other one. Okay, next example. Another one with different signs, because the last sign here is a negative, and when you multiply and you want to get a negative 48, you definitely need different signs. Okay, also note that we're not always using x here, we're using different letters, we're using r in this case. Alrighty, so I'm going to break up 48, and I'm thinking about my factors. And I do know that the factors of 48 are 6 and 8, and those are the ones that are going to get me to 2. And remember, this guy here is negative, so different signs. So what would make sense? Would it make sense for the 6 to be here and the 8 to be here? The answer would be no to that, because negative 8 and 6 make a negative 2. I don't want a negative 2. I want a positive 2. Okay, so I'm going to put 8 and 6 here. Okay. Again, the video that's going to be attached to this lesson will have also calculator tips and tricks for lesson 6 with factoring, and the way you can check that this is correct. So like, you would need to see that this and this are equivalent, and you could do that by plugging this into y1, this into y2, and looking at the table, because these guys are the same. It's just that they're written differently. This is in standard form, this is in factored form. And the goal of this lesson is to factor. Where are we up to? How many more we got? 2 more? Okay, another one with the last sign negative. So what does that mean? Different signs. Because when you add and multiply, when you multiply to a negative, you need to have a positive number and a negative number to make that happen. Okay, 72. Factors of 72. Definitely 9 and something. We got 12 and 6. We got 1 and 72. We got 2 and 36. I think that's correct. So the ones that would work here would be 12 and 6. Okay, and the reason why is because we know 12 minus 6 gets you that adding of 6. Because remember, your goal is to multiply to this guy, but add to this guy. Okay. Last one. Okay, so with this one, it's a little bit different. It's a trinomial, but oh my goodness, they put an x to the 4th in the front. Why are they doing that to us? Because we need to think critically here. We need to realize that this is a trinomial, and it's not that much different than the other things we're doing. I want to try to compare these two. So if you see 6 and 8, this is what I'm going to compare it to. Notice the comparison of 6 and 8. First off, they're both trinomials in the fact that they have 3 terms. 1, 2, 3, 1, 2, 3. When that happens, you're going to try to use the AM method. But this one's not a squared, but that's really okay, because think about this logically. This is r squared, right? And you break it up into r and r, okay? And notice that the middle term is just r. And the reason why that's the case is because when you box method this, right, to get back to your original, you would get r squared, you get 8r, you get negative 6r, and you get that negative 48 that we want. If you notice, when you combine the like terms, that's where that positive 2r comes into play, and you get back to your original. This one, however, has an x to the 4th, okay? And when you split up x to the 4th, it would become x squared and x squared, because that's how you would split it up evenly. And notice the middle term is x squared. And just like the last one, It makes sense because this was r squared, this is r, and we broke it up into r and r because it makes sense to split r squared up into r and r. Just like it would make sense to break up x to the fourth into x squared and x squared. And notice the middle term's x squared. So this is completely a thing that we can do AM on because it's 3 terms and this power is double of this. That's really the giveaway. So if this was x to the 6th and this was x to the 3rd, you could do it. If this was x to the 8th and this was x to the 4th, you could do it. This power needs to be double of this one, okay? Alrighty, so we're going to do AM again. Notice that the last sign is positive, so that means the signs will be the same, okay? Now here's the deal. Are they both positive or are they both negative? And what's going to make you know that is the first sign, because you want to add to him. So if you want to add to a negative and you know the signs need to be the same, it would have to be negative and negative to make that happen. Okay, so 27. Let's break this up. Factors of 27. 9 and 3, 1 and 27. Which one would make 12? This guy. But how would you make it negative? Negative and negative. Because again, let's go over this again. When you do -9 times -3, negative times a negative is a positive, and -9 plus a -3 is still a negative. Okay, so that's the numbers I'm going to put here. And you'd think you're done. But this is step 1. If you notice, do you see how there are squareds in here? That means these have the possibility or the chance to be able to be broken up again by x. So let's think. Can I use a factoring method to break up any of these? I'm going to make 4 parentheses just in case. So let's deal with the first one. Is there a type of factoring I can do that would break up x squared and 9? There is. It's the last lesson. It's dots. 3 and 3, plus and minus. Can you break up the 3 like that? No, because 3 is not a perfect square, because it only has the factors of 3 and 1. So my final answer, my fully factored form of this thing, would be x plus 3, x minus 3, and then just tag on that x squared minus 3. Because remember, the goal of factoring is that you're breaking the original up into something that's expanded in a way. This is your standard form. This is your factored form. Okay? And always ask yourself, can you do more? So this was step 1, we used AM, and step 2, we had to combine dots in there to fully factor it. Okay, well I hope this was a good explanation of the AM method. You did do this all in Algebra 1, so it should be somewhat familiar to you. And of course, come to our shop with any questions you may have. I'll see you soon.